Nothing is as far away as it looks. Not the wall across the room, not the streetlight outside your window, not the stars. We move through the world certain that distance is real, a fixed amount of space laid out between one thing and the next, the same for everyone who cares to measure it. But relativity says otherwise. Two people moving differently will measure the gap between the very same objects and get different answers, and neither of them is mistaken. Push the speeds higher, and the disagreement grows until they cannot even agree on how much time separates two events, or which of them came first. The distance you trust so completely turns out to depend entirely on who is asking. So if space itself is negotiable, what is left that everyone agrees on? Before we begin, if this is the kind of slow, strange idea you like to fall asleep to, a quiet like or subscribe really helps this small channel grow, and it means the world to me. Now, let's begin. Part 1. The most solid thing in the world. Reach out in the dark and touch the wall beside your bed. The distance your hand just crossed feels like the most ordinary fact in the world. There was you, and there was the wall, and between the two of you there was a certain amount of space, a gap of a few inches that was simply there, waiting, whether or not you decided to reach across it. Distance feels like that. It feels like the one thing you could never argue about. A meter is a meter. The width of a doorway is the width of a doorway. The space between two things is a plain, settled fact about the world, as solid and as trustworthy as anything you know. I want to spend tonight quietly taking that certainty apart. Not to frighten you, and not to leave you with nothing, but to show you something underneath it that is stranger and steadier than distance ever was. Because the physics of the last century says something about that little gap between your hand and the wall that almost nobody stops to feel the weight of. It says that the distance was never a fact about the world at all. It says that distance is something you bring to the world, the way you bring the lines of a grid to a blank page. And it says that if you could ask two different observers how far apart your hand and the wall really are, they could give you two different answers, and both of them would be exactly right. Give yourself permission, for the next couple of hours, to loosen your grip on the idea that space is the solid stage everything happens on. Your mind will resist. It should resist. This is one of the hardest reorientations in all of science, and the people who first worked it out found it just as difficult as you will. Even the physicist whose name is attached to it spent years wrestling with what it meant. So if a part of you wants to hold on to the good old reliable meter, that is not a failure of understanding. That is the correct starting place. We are going to move slowly, and we are going to keep coming back to the ground so you never quite lose your footing. Let me set up the whole journey in a single simple picture, so you know where we are going. Imagine two people who both want to measure things very carefully. One of them is standing still, here in the room with you. The other is moving, gliding past at an enormous speed, carrying their own ruler and their own clock, both built to the same exacting standard as yours. We are going to ask these two careful people to measure the same things. How long is that object? How much time passed between those two events? Which of these two flashes happened first? And the astonishing thread that runs through this entire episode is that they are going to disagree with each other again and again about answers you would have sworn had only one possible value. And every time they disagree, we are going to check their work, and we are going to find that neither of them made a mistake. Notice how much that violates. When two people disagree about a measurement, we know what to do. We assume one of them was careless. We get a better instrument. We measure again, and the truth settles the argument. The whole idea of measuring rests on the belief that there is a single right answer out there, and our job is to find it. But that is precisely the belief that is going to come apart tonight. These two observers are not going to be careless. Their instruments are not going to be faulty. They are going to measure the same length and get different numbers, and there will be no further measurement, no better ruler, no cleverer technique that can decide between them, because there is no single right answer to decide in favor of. The length itself depends on who is asking. Before we get there, I want to be fair to the meter, because it has served us well. For almost the whole of human history, distance behaved itself. You could pace out a field, and your neighbour could pace it out, and you would agree. You could measure a plank of wood, hand the ruler to someone else, and they would read the same length. Across every ordinary situation any human being has ever been in, distance is stable, shared, and public. It is one of the bedrocks on which we built engineering, architecture, navigation, and trade. So the strangeness we are about to meet is not going to overturn any of that. Your carpenter is not wrong. The gap between your hand and the wall really is a few inches, for you and for anyone sharing your situation. What changes is only revealed when someone moves relative to you at a speed close to the speed of light, and at those speeds our ordinary intuitions were never tested, so they were free to be wrong the whole time without anyone noticing. That is the quiet trap in all of this. Our sense that distance is absolute was built entirely from slow experience. We have only ever measured things while ambling along at the pace of a walk, a car, an airplane, speeds that are a rounding error next to the speed of light. And a belief that has only ever been tested in slow, gentle conditions can feel completely certain, and still be an approximation, a special case of something larger that only shows its true shape when you push it. Distance is like that. What feels like an eternal law is actually the low-speed corner of a richer and stranger rule. And for the whole of history, we lived in that corner and mistook it for the entire house. Consider how strange it is that we ever trusted distance so completely, given how little of the universe our senses were ever built to handle. A human being evolved to catch a thrown stone, to judge the leap across a stream, to know how far the fire sat from the sleeping child. Every one of those judgments happens at speeds so far below the speed of light that the corrections we are going to meet tonight are smaller than anything a body could ever feel. Our intuition about space is a tool honed for one narrow corner of reality, the slow and the nearby, and it works flawlessly there. The mistake was never in using it. The mistake was only in assuming that a tool sharpened entirely on the slow world would keep telling the truth when we finally pushed into the fast one, where it had never once been tested. There is a small piece of history that makes this even sharper, and it hides inside the meter itself. When people first tried to agree on a standard length, they defined the meter as 1/10,000,000th of the distance from the equator to the North Pole, a line drawn across the Earth by human decision. Later they abandoned that and defined it instead by a single bar of platinum and iridium kept in a vault outside Paris, so that a meter was, quite literally, however long that one particular object happened to be. And today we define it in yet another way, as the distance light travels in a tiny, fixed fraction of a second, a little under 1/300,000,000th of a second. Look at what that means. The unit we use to measure all distance is now defined in terms of time and the speed of light. The most basic ruler humanity owns is built out of the very things relativity says are woven together. We reached for something absolute to measure space with, and every time we ended up leaning on an agreement, a chosen object, a human convention. Distance never came with its own tick marks. We supplied them over and over, and then forgot that we had. So keep your hand on the wall a moment longer, and hold the feeling of that little gap. Hold how obvious it is, how impossible to doubt, how plainly just there. That feeling is the thing we are going to follow all the way down, and by the end of the night, it is going to mean something completely different than it does right now. The gap is real, in the only way that matters to you tonight, but whether it is a fact about the world or a line you are quietly drawing across it is a question we have not yet earned the right to answer. To earn it, we have to watch that solid, trustworthy distance do something it should never be able to do. We have to watch it change. Part 2. The first crack. Let me introduce the first crack gently. because it is the one that lets all the light in. Take a simple object, a metal rod, exactly 1 meter long. You measure it, your friend measures it. Everyone who has ever measured it agrees. 1 meter. Now set that rod moving. Not at the speed of a thrown ball, but at a speed that is a real fraction of the speed of light, the kind of speed at which the strangeness wakes up. And measure its length again, carefully, while it moves. What you find is that the rod is shorter, not because it was squeezed, not because anything pushed on it, not because your eyes were fooled. The rod, measured properly while it moves past you, is genuinely shorter along its direction of motion than it was when it sat still. This is called length contraction, and it is one of the plainest and best tested facts in physics. Sit with how odd that already is before we make it stranger. Nothing touched the rod. No force compressed it. It simply moved, and in moving it occupied less distance. And here is the first place your intuition will try to save itself. It will say, all right, the rod only looks shorter, there is some trick of light or timing, but the real length is still 1 meter. I understand the pull of that thought, and I have to tell you that it does not survive contact with the physics. The shortening is not an appearance. If you set up a row of detectors and record exactly where the 2 ends of the rod are at one instant, the distance between those 2 recorded points really is less than 1 meter. The space the moving rod takes up has actually shrunk. Now comes the part that turns a curiosity into a crack in the foundation. The effect is symmetric. Suppose you are the one moving, carrying your meter rod, and your friend is standing still watching you go by. From your point of view, you are not moving at all. You are sitting comfortably with your rod, which is a perfectly good meter, and it is your friend who is rushing past in the other direction. So when you measure your friend's rod, the one they swear is a full meter, you find that theirs is the short one. Each of you sees the other's rod as contracted. Each of you is certain your own is the honest meter. And there is no experiment, none, that can settle which of you is right, because the question has no single answer. The length of the rod is not a property the rod carries around by itself. It is a relationship between the rod and whoever is measuring it. This is the sentence I am going to ask you to carry with you through the entire rest of the night, because everything is built on it. 2 careful observers disagree about a length, and none of them is wrong. Say it to yourself slowly. None of them is wrong. It sounds like a contradiction, like saying 2 people can each be taller than the other. But it is not a contradiction, because length, it turns out, was never the absolute thing we assumed. It was always a thing that lived in the relationship between the measured and the measurer, and it only looked absolute because at the crawling speeds of ordinary life, the disagreement is far too small to notice. It is there even now. As a car passes you on the road, it is genuinely measurably shortened along its direction of travel. The amount is so absurdly tiny, a fraction of the width of an atomic nucleus, that no instrument could ever catch it. But it is not 0. The crack was always in the wall. We simply lived too slowly to see it. How much does the rod shorten? That depends entirely on how fast it moves, and the relationship is captured by a single number that is going to follow us through the whole episode. Physicists call it the Lorentz factor, and you do not need the equation, only the feel of it. At the speed of a car or a plane, the factor is so close to 1 that the shortening is nothing. At half the speed of light, the factor is about 1 1/6, so lengths shrink by a modest amount. At 99% of the speed of light, the factor is about 7, and the rod is squashed to 1/7 of its resting length. And as you push closer and closer to the speed of light itself, the factor climbs without limit toward infinity, and the rod would contract toward no length at all. The speed of light sits at the edge of this like a wall you can never quite reach, and as you approach it, distance itself begins to melt. I want to slow down here and let the quiet strangeness of this settle over you, because we have already left the world you thought you were living in. You have always believed that an object has a size. A table is so many centimeters across. A room is so many meters long. That size felt like it belonged to the object, stamped into it, one of its permanent properties, like being made of wood. And what relativity is telling you, in this very first crack, is that size is not a property an object owns. It is a relationship, negotiated freshly between the object and every observer, and different observers get different answers, all of them correct. The table does not have a width. The table has a width for you, and a different width for someone rushing past, and the universe holds no opinion about which of you has found the true one, because there is no true one to find. You might reasonably ask why this happens at all, why simply moving should make a length shrink, and the answer is the quiet engine behind every strange thing we will meet tonight. It comes down to one stubborn fact about light. No matter how fast you move toward a beam of light or away from it, you always measure that light passing you at the same fixed speed, a little under 300,000 kilometers every second. This sounds harmless, even boring, until you follow it through. In ordinary life, speeds add up. If you run towards someone throwing a ball, the ball comes at you faster than if you stood still. But light refuses to play that game. Run toward it, race away from it, the light comes at you at exactly the same speed either way. And once you insist that the speed of light must come out the same for everyone, something has to give to make the arithmetic work, because speed is just distance divided by time. If the speed cannot change, then distance and time themselves must bend to keep it constant. Length contraction and time dilation are not separate mysteries bolted onto the world. They are the price reality pays to keep the speed of light the same for every observer, no matter how they move. So the shrinking rod is not being crushed by any force, and nothing is physically squeezing it. It is that the very meaning of length, the distance the rod occupies, is tied up with measurements of space and time that must adjust themselves so that light always clocks in at the same speed. Change your motion, and you change the angle at which you slice space from time, and the rod's length changes with it, not because anything happened to the rod, but because you are now measuring it against a differently tilted framework. This is the first hint of the thing we are building toward all night, that space and time are not the fixed backdrop we imagined, but a flexible pair, trading against each other, held in a balance by the one truly fixed thing, the speed of light. The rod was never the strange part. The strange part is what space and time are willing to do to protect that single unchanging speed. If length can slip like this, if the most solid measurement we have can hold two different values at once and betray no error, then a question begins to form that we will not be able to put down. What else that we trusted is like this? What other bedrock facts are secretly relationships wearing the mask of absolutes? And the answer, it turns out, is that the betrayal does not stop at distance. The very next thing to go is the one we lean on even more heavily than space. Because if you thought it was unsettling to watch a ruler change its length, wait until you watch a clock change its time. Part 3. The clocks disagree too. Everything that just happened to space happens to time as well, and if anything it lands harder, because time feels even more untouchable than distance. A moving clock, measured carefully as it passes you, runs slow. Not because it is a cheap clock, not because something is interfering with its gears, but because time itself, for that moving clock, passes at a different rate than it does for you. This is called time dilation, and like length contraction, it is symmetric, real, and confirmed to staggering precision. The faster something moves relative to you, the slower its time runs. From your point of view, governed by the very same factor that shrinks the moving ruler. Let me make sure the symmetry lands, because it is where the vertigo lives. You watch a clock fly past, and you see it ticking slowly, lagging behind your own. But from the point of view of that clock, it is you who are moving, and it is your clock that is running slow. Each of you sees the other's time as dragging. Each of you is right. There is no master clock hanging in the sky against which all the others can be checked, no true time that the universe keeps in a back room. There is only your time and their time, and the two need not agree, and neither is the real one. Just as length turned out to be a relationship rather than a property, so does the passage of time. How much time separates two events is not a fact the universe stores. It is a number that depends on who is moving how. I know how close this sails to sounding like a philosopher's word game, so let me anchor it in something you cannot argue with, something that is happening in the sky above you right now. There are particles called muons, created when cosmic rays strike the upper atmosphere, about 15 kilometers up. A muon is unstable. Left to itself, sitting still, it survives for only about 2/millionths of a second before it falls apart. 2/millionths of a second is not nearly enough time to fall 15 kilometers, even at nearly the speed of light. By every reckoning that ignores relativity, these muons should decay high in the air, and almost none of them should ever reach the ground. And yet detectors at sea level catch them in floods. They arrive in enormous numbers, having crossed a distance that their own short lifespan should have made impossible. Both observers in this little drama agree on the one fact that matters, which is that the muon arrives, but they explain it in two completely different ways, and this is the beautiful part. From our point of view, standing on the ground, the muon's internal clock is running slow because it moves so fast, so its 2/millionths of a second stretch out, from our vantage, into enough time to complete the trip. But now ride along with the muon, and it insists its own clock is perfectly normal, ticking off its brief 2/millionths of a second exactly as always. From the muon's point of view, what saves it is the other effect, the one we met a moment ago. The 15 kilometers of atmosphere, rushing toward the muon at nearly the speed of light, is length contracted, squashed down to a small fraction of its depth, a distance short enough to cross in the muon's ordinary lifetime. One observer says time stretched. The other says space shrank. They disagree completely about what happened, and they agree completely that the muon reaches the ground. None of them is wrong. If you would rather have something built by human hands than something raining out of the sky, the machine in your pocket will do. The satellites of the Global Positioning System carry clocks of extraordinary precision, and those clocks are moving fast, thousands of kilometers an hour, in orbit high above you. Their speed makes their clocks run slow relative to the ground, and their altitude, through a separate effect of gravity we will leave aside tonight, makes them run fast, and the two combine to a net difference of about 38 millionths of a second per day. That sounds like nothing, but the system works by timing signals to the billionth of a second, and if the engineers did not correct for that relativistic drift, the navigation would be wrong by about 10 kilometers after a single day, and grow worse every day after. Every time a map on a screen quietly knows where you are, it is because someone accounted for the fact that time runs at different rates for the satellite and for you. Time dilation is not a thought experiment. It is a line item in the engineering of ordinary life. I want to press on one point that people often try to wriggle out of, because it is the point where time dilation stops being about clocks and starts being about you. When we say a moving clock runs slow, it is tempting to imagine that only the mechanical clock is affected, that the hands move sluggishly while the real time underneath ticks on as normal. But there is no real time underneath. Every process that measures or marks the passage of time slows together, in perfect lockstep, because it is time itself that is running differently, not any particular device. The swinging of a pendulum, the vibration of a quartz crystal, the decay of a radioactive atom, and, crucially, every chemical reaction in a living body, all slow by exactly the same factor. Which means that a person moving very fast relative to you would age more slowly from your point of view, their heartbeat, their thoughts, the growth of their hair, everything about them unfolding in slow motion, not because anything is wrong with them, but because less time is genuinely passing along their path. This is the seed of the famous story of the two twins, one who stays home and one who travels out into space at close to the speed of light and returns. When they meet again, the traveller has aged less. Fewer years have passed for the one who moved. This is not science fiction, and it is not a trick of clocks. We have tested it gently by flying extremely precise atomic clocks around the world on ordinary aircraft and comparing them afterward with clocks left on the ground, and the flown clocks come back having ticked a hair less, exactly as much less as relativity predicts, billionths of a second measured and confirmed. Time is not a fixed river carrying everyone along at the same rate. It is more like a road that different travellers cross by different routes, and some routes are genuinely shorter in time than others. Two people can leave the same event, live through what each experiences as an ordinary stretch of life, meet again at a later event, and find that different amounts of time have passed for each of them. The duration of a life between two meetings is not a fixed fact. It depends on the path taken through space and time to get from one to the other. So now both of our bedrock certainties have gone soft in our hands. Distance is a relationship, not a property. Duration is a relationship, not a property. Two observers can disagree about how far apart two things are, and about how much time passed between two events, and in each case both of them are measuring reality correctly. And you can feel, I hope, the ground beginning to tilt, because we lean on space and time to hold everything else steady. They are the stage. They are the graph paper we draw all of physics onto, and the stage is turning out to be different for every observer, the graph paper stretching and shrinking depending on who holds the pen. But we have not yet reached the part that truly empties the floor from beneath the old picture. Losing agreement about how much space or how much time lies between two events is disorienting enough. There is, however, one thing left that feels even more untouchable than the amount of space or the amount of time. It is the order of events. The simple, absolute, surely unarguable fact of which thing happened first. You would think, whatever else slips, that at least the sequence of events would hold. That if one thing came before another, it came before another, full stop for everyone. Hold on to that conviction for just a moment longer, because it is the next thing we are going to lose, and it is the one whose loss changes everything. Part 4. Whose past is whose future. Picture a long station platform late at night, quiet and almost empty, and you are standing at the very middle of it. A train is coming, but not an ordinary train. This one glides past at a speed close to the speed of light, which no real train could ever do, but the physics does not mind our pretending, because the effect is real at any speed and only becomes dramatic at this one. As the train streaks by, two bolts of lightning strike the platform. One far to your left, one far to your right, each one leaving a scorch mark on the ground and a matching scorch mark on the train as it passes. You are standing exactly halfway between the two strikes. The light from each one races toward you across equal distances, and it reaches your eyes at the very same instant. You saw both flashes together, and since you know you were exactly in the middle, you conclude correctly that the two strikes happened at the same moment. They were simultaneous. One instant, two sparks. Now step inside the train and sit beside a passenger who was seated at its exact centre as it rushed past. She is moving toward the flash on the right and away from the flash on the left, carried by the train at tremendous speed. The light from the right strike, the one she is racing toward, has less distance to cover to reach her, because she is rushing to meet it. The light from the left strike, the one she is speeding away from, has to chase her down. And because light travels at the same fixed speed for her as for everyone, the light from the right reaches her first. She sees the right flash, and then, a moment later, the left. And she is every bit as careful as you are. She knows she was sitting at the centre of the train. She knows the light came to her at a fixed speed. So she concludes, correctly, by exactly the same reasoning you used, that the right strike happened first and the left strike happened second. Not at the same time. One before the other. Stop and feel what has just happened, because it is the moment the floor gives way. You said the two strikes were simultaneous. She said the right one came first. You are both right. There is no measurement, no better vantage point, no cleverer clock that can settle which of you has the true order of events, because there is no true order to settle. The sequence of events, the plain fact of which one happened first, is not written into the world. It depends on how you are moving. Two people, both careful, both correct, disagree not about how far apart or how long between, but about which thing happened first. None of them is wrong. This is the relativity of simultaneity, and it is the quiet detonation at the centre of the whole theory. Because think about what it means to lose a universal order of events. It means there is no single, shared present moment, that the entire universe passes through together. Your now and her now slice through the events of the world along different angles, like two knives cutting the same loaf at different tilts. Events that lie in your present may lie in her past or her future. For strikes on a platform a few hundred meters apart, the disagreement is a sliver of a second, far too small to matter. But the size is not the point. The point is that the disagreement exists at all, because any disagreement whatsoever means the universal now is gone. There is no cosmic clock marking out the same present for everyone. There is only a great many observers, each carrying their own present, and the presents do not line up. Let me draw out the part that reaches into your chest and not just your head, because this is where the physics stops being a curiosity and starts being about you. We move through our lives certain of a particular story about time. The past is fixed and gone. The future is open and not yet real. And the present is the thin, bright line where we live and act and change what is coming. That story requires a universal now, a single present that everyone shares, dividing the settled past from the open future for all of us at once. And relativity has just taken that away. If there is no shared present, then there is no agreed line between what is over and what is yet to come. For someone moving relative to you, an event you consider part of your open, unwritten future may already lie in their settled past. Somewhere, from some valid point of view, the thing you are still deciding whether to do is already behind someone else, already done. The future that you are so sure you are free to shape is, from another equally correct vantage, finished. I am not going to rush past that, because it deserves to be felt rather than solved. The loss here is not a number or a measurement. It is the loss of the shared present, the thing every human being who has ever lived has quietly assumed we were all standing in together, this common moment we call now, moving forward in step. Relativity says there is no such thing. There is no now that spans the universe. Your present is yours, a particular slice at a particular tilt, and it is as valid as anyone's, and no more valid than anyone's, and it does not reach beyond your own motion to touch anyone else's. We are each alone inside our own present, and the presents will not be made to agree. Let me give you a way to picture how the disagreement scales, because the size of it is part of the wonder. The amount by which two observers disagree about the timing of distant events grows with the distance to those events, and with how fast the observers move relative to each other. For two people strolling past each other at walking pace, and for two lightning strikes a few hundred meters apart, the disagreement about which came first is a sliver of time so small that no clock ever made could measure it, a tiny fraction of a billionth of a second. But keep the walking pace and push the events far away, out to a star many years of light travel from here, and that same gentle difference in motion opens the disagreement about what is happening there now into minutes. Push the distance further, across the width of a galaxy, and two people who merely turn and walk the other way can carry nows that differ, at that faraway place, by days or even years. One of them can have a distant event already finished in their present, while for the other it has not yet happened, and the only difference between them is the direction of an evening stroll. Sit with how quietly outrageous that is. Whether a particular event, far across the universe, lies in your past or your future, can depend on nothing more than which way you happen to be walking down your own street. There is no faraway master clock ticking out the real now for everyone. There is only the tilt of each observer's present, and that tilt swings with the smallest change in motion, and it fans out the further away you look, until the notion of a shared present moment spanning the cosmos simply has nothing left to stand on. The now you feel so certain of, the one you imagine stretching out across the whole universe at this very instant, reaches only as far as your own immediate surroundings before it comes apart into 1,000 equally valid answers. Now, before that thought carries us somewhere too dark for the hour, let me plant the seed of the rescue, because there is one, and it is the whole point of tonight. You might expect that if observers cannot agree on distance, or on duration, or even on the order of events, then physics would collapse into pure chaos, with every observer trapped in a private universe and nothing held in common between them. But that is not what happens, and the fact that it is not is the most important thing in this entire episode. Underneath all this disagreement, there is something every observer agrees on completely. There is a bedrock, and it was there the whole time, hidden beneath the shifting numbers. When you find it, you discover that the things we thought were fundamental, space and time, are the negotiable surface, and the thing we never noticed is the solid rock below. Finding that rock is where we go next, and it changes what the word reality is even allowed to mean. Part 5. If everything dissolves, what is left? Let me gather up where we stand, because we have pulled 3 certainties out from under ourselves, and it is worth feeling the full weight of the whole before we climb out of it. Distance is not absolute. 2 observers measure the same object and get different lengths, both correct. Duration is not absolute. 2 observers measure the time between the same 2 events and get different amounts, both correct. And now order is not absolute either. 2 observers watch the same pair of events and disagree about which came first, and both are correct. Space, time, and sequence, the 3 struts we hang the whole of experience on, have each turned out to be relationships rather than facts, different for every observer, with no privileged answer anywhere. Faced with this, it is tempting to leap to a conclusion that sounds sophisticated and is completely wrong. So I want to head it off now, because you will meet it out in the world, dressed up as wisdom. The tempting conclusion is that everything is therefore subjective, that relativity proves there is no objective truth, that reality is just whatever each observer perceives, and no view is any truer than any other. People say this. They say relativity shows that everything is relative, that it is all a matter of perspective, that science itself has confirmed there are no absolutes. And it is one of the most backwards readings of a scientific idea that has ever taken hold, because relativity says almost exactly the opposite. It does not abolish objective reality. It relocates it. It takes objectivity away from the places we expected to find it, space and time, and hands it to a place we never thought to look. Here is the clue that something objective is still there, and it is a strong one. Every one of our disagreeing observers, no matter how they move, agrees on the laws of physics themselves. They all measure light moving at the same fixed speed. They all find the same equations governing how things behave. The disagreements are never about the rules. They are only about certain quantities the rules are written in terms of. And whenever you find people who disagree about the surface numbers, but agree completely about the underlying laws, you should suspect that there is some deeper quantity built out of the surface numbers that they all actually agree on, and that this deeper quantity is the real physical thing, while the surface numbers were only ever its shadow cast at different angles. Think of it like this. Imagine several people standing around a tall sculpture, each holding a lamp, and each looking only at the shadow the sculpture throws on the wall behind it. One person, with their lamp low and to the side, sees a tall, thin shadow. Another, with their lamp high and straight on, sees a short, wide shadow. If these people only ever looked at the shadows and never at the sculpture, they would argue forever about the true height and the true width of the thing, and they would never agree, because height and width of the shadow depend entirely on where you hold the lamp. But the sculpture itself has not changed at all. It has a definite shape, sitting there in 3 dimensions. The same for everyone. The disagreement about the shadow's height and width is not a sign that there is no truth. It is a sign that height and width of the shadow were never the real properties. The real property is the shape of the sculpture, and the shadows are just its projections, flattened and distorted by the angle of each lamp. That is exactly the situation we are in with space and time. The different lengths, the different durations, the different orderings that our observers measure are like the different shadows. They are projections of something, flattened at different angles depending on how each observer moves. And if that is right, then somewhere there is a sculpture, some single unchanging thing that casts all these different shadows of space and time, some quantity that every observer computes and every observer agrees on, no matter how they move. Find that and you have found the thing that is actually real, the object rather than its shadow. The disagreements about distance and duration would then be exactly as meaningful as the disagreements about the shadow's height, which is to say, real as measurements but not fundamental as facts about the world. So the question sharpens to a single point, and the rest of the night hangs on it. Is there such a quantity? Is there something built out of the space between two events and the time between two events that comes out the same for every observer, however they are moving? If there is not, then perhaps the pessimists are right, and it really is all just perspective with nothing underneath. But if there exists even one number that everyone agrees on, then that number is a doorway. It is the shape of the sculpture behind the shadows, and following it will lead us to a completely different picture of what the universe is made of, one in which space and time are not the fabric of reality, but the grid we drape across it. There is a piece of this worth pausing on, because it corrects the single most common misunderstanding of the whole theory, the one buried in its very name. People hear the word relativity and conclude that the lesson is that everything is relative, that nothing is fixed, that all is a matter of viewpoint. But the working physicists who built and use this theory tend to see it almost the opposite way, as a theory about what stays the same. The entire method of the thing is to hunt down the quantities that every observer agrees on, the invariants, and to treat those as the real physics, while the quantities that change from observer to observer are demoted to mere appearances. Einstein himself is said to have been unhappy with the name relativity, and to have preferred something like a theory of invariance, a theory of the things that do not change. The disagreements about space and time are not the point of the theory. They are the puzzle the theory exists to solve, and it solves them by finding what lies underneath that everyone shares. This is how physics has always found its way to what is real, by asking what survives a change of perspective. When you walk around a solid object, its appearance changes constantly, its outline, its shading, which face you can see, and yet you never doubt that the object itself is one fixed thing, because you understand that the changing views are projections of an unchanging shape. The shape is what is real, precisely because it is what all the views have in common. Physics does the same thing on a grander scale. It treats a quantity as physically real to the exact degree that it stays the same when you change how you look at it. By that standard, the length of a moving rod and the time between two events are not fully real, because they change with the observer. If there is to be something real underneath them, it must be something every observer computes and every observer agrees on, an invariant hiding inside the disagreements, waiting to be found. There is such a quantity. It was found within a few years of relativity itself, and at first it looked like nothing more than a lucky piece of bookkeeping, a convenient combination that happened to stay fixed. But the man who understood what it truly was saw that it was not bookkeeping at all. He saw that it was the real geometry of the world, and that space and time were the shadows. We are about to meet that quantity, and I want you to watch it closely, because it is the most important number you have never heard of. It is called the spacetime interval, and everyone in the universe agrees on it. Part 6. The one number everyone agrees on. Let me build the spacetime interval up slowly, because it is simpler than it sounds and stranger than it looks. Take any two events. By an event I just mean a specific happening at a specific place and a specific moment, a firecracker going off here and now, a hand touching a wall there and then. Between any two events, an observer can measure two things. They can measure the distance in space between where the two events happened, and they can measure the interval in time between when the two events happened. We have already seen that two observers who move differently will disagree about both of these. One will say the events were far apart in space and close in time. Another, rushing past, will say they were close in space and far apart in time. The space measurement and the time measurement each slosh around from observer to observer. Now here is the quiet miracle. Take the time between the events and the distance between the events and combine them in a particular way. You take the amount of time and you square it. You take the amount of distance and you square it. And then, instead of adding them the way you would to find an ordinary diagonal, you subtract one from the other. That subtraction is the whole secret, so hold on to it. Ordinary geometry adds, to find the straight line distance across a room, you square the length and the width, and you add them and take the root. That is the rule of the world we can see, and it always adds. But spacetime does not add. It subtracts. It takes the square of the time separation and the square of the space separation, and it finds the difference between them. And that difference, that single combined number, is the spacetime interval between the two events. The reason this matters, the reason it is not just idle arithmetic, is what happens when different observers each compute it. Every observer disagrees about the time between the events. Every observer disagrees about the distance between the events. But when each of them squares their own time, squares their own distance, and takes the difference, they all arrive at exactly the same number. The disagreements cancel. Where one observer had more time and less space, another had less time and more space, and the particular way the interval subtracts one from the other means the two changes precisely compensate. The surface numbers shift and slide from observer to observer, and the interval underneath stays rock still. It is the one measurement about a pair of events that the entire universe agrees on. Imagine you could hold two events in your mind like two pins stuck into the fabric of reality, and imagine you could watch what different observers say about the separation between them. One observer, standing still, tells you the events were a long way apart in space and only a short time apart in the clock. Another observer, sweeping past at great speed, tells you the opposite, that the events were almost on top of each other in space, but separated by a long stretch of time. As you turn from one observer to the next, you watch the space part shrink and the time part grow, or the time part shrink and the space part grow, the two quantities pouring into each other, one filling as the other empties, like sand shifting between two chambers. And through all of it, the combined interval, the difference between the squared time and the squared space, does not move at all. It sits there, fixed, serene, the same for every single observer, a length that refuses to change no matter how you turn it. That unmoving number is the first solid thing we have touched all night, and it is solid for everyone. There is a beautiful way to understand what the interval actually measures in the most common case, and it ties this abstract number back to something as ordinary as a wristwatch. When two events are close enough in space and far enough in time that something could travel from one to the other, the interval between them is, quite literally, the amount of time that would tick by on a clock, carried along that trip. It is the elapsed time as measured by whoever actually makes the journey from the first event to the second, the reading on their own watch when they arrive. Physicists call this the proper time, and it is the interval given a human face. So the strange invariant quantity everyone agrees on is not some cold mathematical abstraction after all. It is the felt duration of a life lived along a particular path, the time you yourself would experience travelling from here to there. This is what really lies behind the story of the two twins, and it turns their puzzle into a piece of pure geometry. The twin who stays home and the twin who flies away and returns both travel between the same two events, their parting and their reunion, but they take different paths through the four-dimensional world to get there. And here is the part that upends intuition once more. The path that looks longer in ordinary space, the great loop out into the stars and back, is actually the shorter path in space-time interval, in proper time, which is why the traveller ages less. In the strange geometry of the four-dimensional world, with its telltale minus sign, the straight stay-at-home path racks up the most time, and every detour through space subtracts from the total. The interval is not just some number that happens to stay fixed. It is the true measure of duration along a path, the real time a real clock keeps, and the reason two lives that begin and end at the same two moments can nonetheless contain different amounts of experienced time. Distance and duration were shadows, but the interval is the solid thing, and it turns out to be nothing more exotic than the ticking of a watch carried faithfully from one event to another. What we have found, then, is our sculpture. The distances and durations that each observer measures are the shadows, thrown at different angles by different motion. The spacetime interval is the object casting them, the real shape that stays the same behind every projection. And the strange subtraction, the minus sign that makes the interval a difference rather than a sum, is telling us something profound about the kind of space this really is. It is not ordinary space where everything adds. It is a stranger geometry in which time enters with the opposite sign from space, a geometry the mathematicians call non-Euclidean, meaning it does not obey the flat rules of the ruler and the drafting table. Time is not just a fourth direction tacked on beside the three of space. It is a direction of a different character, one that enters the true distance formula with a minus where the others have a plus. That single difference of sign is the reason time feels so unlike space to us, even though they are woven into the same fabric. I want to be honest that when this interval first appeared, it could have looked like a coincidence, a fortunate cancellation with no deeper meaning, the kind of thing that shows up in the mathematics and gets filed away as a curiosity. Plenty of true things in physics are just convenient combinations with no grand significance. But the interval is not one of those, and the person who realized this changed the shape of physics permanently. He looked at this quantity that everyone agrees on, this fusion of space and time with its telltale minus sign, and he asked a daring question. If everyone agrees on this, and no one agrees on space or time alone, then maybe this is what is real, and space and time alone are the illusions. Maybe reality is not a three-dimensional space that changes as time flows. Maybe reality is a single four-dimensional thing, and the interval is a distance within it, and what we call the passage of time and the separation of space are just the way we, from the inside, carve that one thing into pieces. To see what he meant, we have to look closer at what the interval is actually telling us, because hidden inside that minus sign is the most profound secret of all. Hidden inside it is causality. Part 7. 3 kinds of separation. The spacetime interval hides a further secret in the fact that its subtraction can come out 3 different ways, and each way describes a completely different relationship between 2 events. Because the interval is a difference, the square of the time part minus the square of the space part, it can turn out positive, or it can turn out 0, or it can turn out negative. In ordinary geometry, that never happens. A squared distance across a room is always positive, always a real length. But this stranger geometry allows all 3 outcomes, and rather than being a flaw, those 3 cases turn out to sort every pair of events in the universe into 3 exact categories. Once you see the categories, the whole disagreement about order that unsettled us earlier suddenly makes complete and orderly sense. Consider the first case where the time part wins, where there is more time between the events than there is space, so the interval comes out on the time-like side. When 2 events are separated like this, there is enough time for something travelling slower than light, something ordinary, a person, a signal, a thrown ball, to leave the first event and arrive at the second. The 2 events are close enough in space and far enough apart in time that you could actually get from one to the other without breaking the speed limit of the universe. Physicists call this a time-like separation, and here is the crucial thing about it. When 2 events are time-like separated, every single observer, no matter how they move, agrees on which one came first. The order is not up for grabs. There is no vantage point from which the sequence flips. Everyone agrees. Now consider the opposite case, where the space part wins, where there is more space between the events than there is time. so the interval comes out on the space-like side. When two events are separated like this, they are so far apart in space and so close together in time that nothing could possibly travel from one to the other. To connect them, you would have to move faster than light, which nothing can do. They are, in the most profound sense, out of reach of each other. Physicists call this a space-like separation, and here is its crucial feature, the one that resolves everything. When two events are space-like separated, observers disagree about their order. Some see the first one first, some see the second one first, some see them as simultaneous, and none of them is wrong. The order genuinely is not fixed. This is exactly the situation of our two lightning strikes on the platform. They were space-like separated, too far apart in space for any signal to have crossed between them in the sliver of time involved. And that is precisely why you and the passenger could disagree about their order without either of you being mistaken. Between these two lies the knife edge, the case where the time part and the space part are exactly equal, so the interval comes out to precisely 0. This is the path of light itself. A flash of light leaving the first event arrives exactly at the second, no sooner and no later, because light covers exactly as much space as there is time for it to cover, no more and no less. Physicists call this a light-like or null separation, and along it the space-time interval is exactly perfectly 0. This is the strangest and most beautiful case, and we touched it in an earlier journey together, so I will only pause on it briefly tonight. Along a ray of light, the separation between where it began and where it ended, measured in the true geometry of space-time, is nothing at all. For light, the two ends of its journey are, in the most profound sense the interval knows, the same point, 0 apart. The distance that looks so real to us, the light years across which starlight travels, is 0 to the light itself. Even here at the very edge, distance dissolves. Put the three cases together, and something orderly rises out of what had felt like chaos. Every pair of events in the universe falls into exactly one of these three categories, fixed and agreed by everyone, because everyone agrees on the interval. Either the events are time-like separated, close enough to be reached one from the other, and everyone agrees on their order, or they are light-like separated, connected only by a beam of light, and everyone still agrees on their order, or they are space-like separated, too far apart for anything to cross between them, and only then does the order become a matter of the observer. The disagreements about sequence that seem to threaten all of reality turn out to be perfectly contained. They happen only, and always, between events that could never have affected each other in the first place. Let me make these categories concrete with something over your head right now. The nearest star, the sun. The light reaching you from the sun left its surface about 8 minutes ago, because the sun sits roughly 8 light minutes away, which is simply to say that light, the fastest thing there is, needs 8 minutes to cross the gap. Now think about what that means for the categories. Whatever is happening on the sun at this very instant, as you experience your own now, is completely beyond your reach. No signal, no influence, nothing at all could travel from the sun's surface as it is right now to you as you are right now, because that would require crossing 8 minutes of distance in no time at all. The sun's present and your present are space-like separated, off in each other's elsewhere, causally cut off. If the sun were to stop shining this instant, you would have no way of knowing for a full 8 minutes, and during those 8 minutes, the fact of it simply would not be part of your reality yet. But wait 8 minutes, and everything changes. The sun's surface as it was 8 minutes ago sits exactly on your past light cone, connected to you by the light now entering your eyes, and about that you and every other observer completely agree. That earlier moment of the sun can affect you, is affecting you, in the warmth on your skin and the light in your room. So the same sun occupies two utterly different relationships to you depending on which moment of it you mean. Its now is in your untouchable elsewhere. Its 8 minutes ago is on your past light cone, reaching you this very second. The line between what can touch you and what cannot is not drawn by distance alone, nor by time alone, but by the two together, exactly in the pattern the interval describes. Your causal neighborhood is not a ball of space around you. It is a pair of cones in spacetime, and everything real about your connection to the universe lives inside their shape. There is a way of drawing this that physicists carry around in their heads, and I want to give it to you because it turns the three cases into a single picture. Stand at any event, here, now. Draw the paths that light could take leaving this moment, spreading outward into the future, and you get a widening cone, the future light cone, containing every event you could ever reach or influence. Draw the paths of light arriving at this moment from the past, and you get a second cone opening backward, the past light cone, containing every event that could ever have reached or influenced you. Everything inside those two cones is time-like or light-like related to you, and your order relative to all of it is fixed and shared by everyone. And everything outside the cones, off to the sides, is the space-like region, close in space perhaps, but forever beyond causal reach, the place physicists call the elsewhere, where the notions of before and after have no fixed meaning. This picture, two cones meeting at the point of now, is the true shape of your relationship to the rest of the universe, and it is going to tell us what the interval has really been about the whole time. Part 8. The Interval is Causality. We are ready now for the turn that the whole night has been building toward, and I want to take it slowly, because it is the hinge on which everything swings. We have found that the spacetime interval sorts every pair of events into three categories, and that observers agree on the order of events except in one case, the space-like case, where nothing could travel between them. Now look at what those three categories are really about. A time-like separation means something could get from one event to the other. A light-like separation means light, and only light could get from one to the other. A space-like separation means nothing could get from one to the other. In other words, the space-time interval between two events is not fundamentally telling you how far apart they are in space, or how far apart they are in time. It is telling you whether one of them could have influenced the other. The interval is a measure of causal contact. Let that land, because it recasts everything we have seen. The one quantity that every observer in the universe agrees on, the solid rock beneath all the shifting sand of distance and duration, is at bottom a statement about causality, about what can affect what. When the interval says two events are time-like or light-like separated, it is saying a cause at the first could have produced an effect at the second, and everyone agrees on the order because cause must come before effect, always for everyone. When the interval says two events are space-like separated, it is saying no cause at either could ever reach the other. They are causally cut off, and precisely because neither can influence the other, it does not matter which one you call first. The order of causally disconnected events is free to be disputed, because nothing depends on it. Nothing hangs on the sequence of two events that can never touch. This is why the disagreements never descended into chaos, and it is worth feeling the relief of it. You might have feared, back when order first dissolved, that this loose sequencing could let effects come before their causes, that someone might see a window break before the ball reaches it, or a person arrive before they set out. That never happens, and now we can see exactly why. The only events whose order observers dispute are events that could not possibly be cause and effect, because no signal could cross between them. Any two events that actually could be linked by cause and effect, any two events where one could have reached out and made a difference to the other, are time-like or light-like separated, and their order is fixed and shared by every observer in the universe. Causality is never violated. The sequence of causes and effects is the one sequence that everybody agrees on. Ironclad, universal, the same from every point of view. What observers argue about is only ever the order of things that have nothing to do with each other. Stand again at that single event, here, now, this breath, and feel the shape of it in the light of what we now know. Out ahead of you opens the future light cone, and it is not just a geometric region. It is the set of everything you could ever affect, Every event you could still reach out and touch. Every place a choice made here and now could send a ripple. Behind you opens the past light cone, and it is everything that could ever have reached you, every cause whose effects have shaped this moment, the whole inheritance of influence that made your now what it is. And all around, filling most of the universe, lies the elsewhere, the immense region that is close to you in raw distance yet utterly beyond your causal reach, events you can neither affect nor be affected by no matter what you do. That cone of reachable events, and not the flat expanse of space around you, is your true position in reality. It is the honest map of where you are, and it is drawn entirely in the language of what you can and cannot touch. This is also the most profound answer to the people who say that relativity proves everything is subjective, and it is worth returning to that misunderstanding now that we can dismantle it completely. The theory does not say that all viewpoints are equally valid, and there is no fact of the matter about anything. It says something far more disciplined. It says that the things you thought were absolute, distance and duration and order, are viewpoint dependent, and it replaces them with something that is not viewpoint dependent at all, the causal structure, which every observer must agree on exactly. Far from abolishing objective reality, relativity is fierce about it. There is a single, observer-independent truth about which events can influence which, and no amount of changing your motion, no clever choice of frame can alter it by the smallest amount. You are free to disagree about how far apart two events are. You are not free to disagree about whether one could have caused the other. That is fixed for everyone forever. A theory with an unbreakable, universal causal order at its foundation is about as far from anything goes as a theory can be. Notice what has quietly happened to distance in all of this. We began the night certain that distance was the solid, fundamental thing, the gap that was simply there between your hand and the wall. And now distance has slipped into the role of the shadow, a projection that different observers measure differently, while the thing casting the shadow, the thing everyone agrees on, has turned out to be causal structure, the web of what can influence what. The universe does not fundamentally keep track of how far apart things are. It keeps track of what can reach what. Distance is our name for one shadow of that deeper fact, thrown at the particular angle of our particular motion. The real relationship between any two events is not the space between them, which is negotiable, but whether a line of cause and effect could ever join them, which is not. This also explains, at last, why nothing can travel faster than light, and it turns a rule that always sounded arbitrary into something that protects the whole order of the world. We usually hear the speed of light described as a cosmic speed limit, a maximum velocity, and it is that, but the framing makes it sound like a mere restriction, as though the universe would work fine at higher speeds and simply forbids them out of stubbornness. The truth is far more interesting. The speed of light is the exact boundary between the events that can influence each other and the events that cannot, between the inside and the outside of the light cone. To send a signal faster than light would be to reach out of your own future cone and touch an event in the elsewhere, an event that some observers see as happening before you sent the signal. And that is not merely forbidden, it would let effects arrive before their causes. Follow that just one step, and you can feel why the universe guards this boundary so absolutely. If you could send a message faster than light, then because different observers disagree about the order of space-like separated events, there would exist an observer for whom your message arrives before you sent it. Chain two such messages together, and you could, in principle, arrange to receive a reply to a question you have not yet asked, or send a warning that arrives in time to prevent the very event that prompted it. The entire structure of cause preceding effect, the structure that lets the world be coherent at all, would unravel. So the speed of light is not a spitefully imposed limit. It is the seam that holds causality together, the precise edge that keeps the disagreements about order safely confined to events that can never affect one another. Break it, and you would not merely go fast. You would tear the causal fabric that makes before and after mean anything. If that is true, then something we have taken for granted our whole lives has been standing exactly backwards, and setting it right is the work of the next part. We have always believed that time is the fundamental thing, the river along which causes flow into effects, and that causality is simply what happens because earlier moments give rise to later ones. Time first, causality second. But look again at what we have found. The thing everyone agrees on is causality. The thing they disagree on is time. The universal, objective, unshakable structure is the pattern of what can affect what. And our sense of a shared, flowing time is the thing that comes apart the moment two observers move differently. So which is really the foundation, and which is the thing built on top of it? The answer is going to invert the order you have carried in your mind since childhood, and once it flips, it does not flip back. Part 9. Causality comes first. We think of time as the stage on which cause and effect play out. First there is time, flowing steadily forward, and within that flow, earlier events cause later ones, the past reaching forward to shape the future along the current of the moving now. In this familiar picture, time is the profound thing, the given, and causality is a pattern that appears inside it, a story told along the timeline. Cause comes before effect, because that is simply what before and after mean, and time is what supplies the before and after. That is the order of things almost everyone carries, unexamined, from the time they are small. Time is the water. Causality is the swimming done in it. Everything we have uncovered tonight suggests that this has it exactly upside down. Consider what actually turned out to be objective and what turned out to be negotiable. The flow of time is not shared. Two observers cannot agree on how much time passes between events, nor even for causally disconnected events on their order. The universal now, the single moving present that the river picture depends on, does not exist. If time were truly the profound foundation, you would expect it to be the thing everyone agrees on, the rock beneath the disagreements. Instead, it is the water that sloshes differently for everyone. Meanwhile, the thing that stands firm, the thing every observer computes identically, is the causal structure, the pattern of what can influence what. The foundation is not behaving like time, it is behaving like causality. So turn the picture over and see how much better it sits. Suppose causality is the fundamental thing, the actual bedrock structure of reality, the fixed web of which events can reach which. And suppose that what we call time is not the river underneath causality, but a kind of summary we extract from it, a way of organizing the causal order into a felt sequence from our own point of view. On this reading, cause does not come before effect, because time happens to flow that way. Rather, the reason we have any notion of before and after at all is that there is a causal order and we read time off it. Time is downstream of causality, not upstream. To whatever extent observers agree about temporal things, it is only because, and only where, causality has fixed the order for them. Where causality falls silent, in the elsewhere, between events that cannot touch, time falls silent too, and observers are free to disagree. I know how strange it is to be told that causality is more fundamental than time, because it runs against a lifetime of intuition. So let me offer a way to feel it, rather than just accept it. Ask yourself what before and after would even mean in a universe with no causes and no effects. A universe of utterly disconnected events that could never influence one another in any way. In such a universe, there would be no fact about which event was first, because nothing would ever depend on the answer, and there would be no signal, no memory, no trace linking any moment to any other. The very idea of order would have nothing to hold on to. Order means something to us precisely because effects carry the marks of their causes, because the present remembers the past and shapes the future, because there are chains of influence running through the world. Take away the causal chains, and you take away the only thing that ever gave before and after any grip on reality. Time needs causality to mean anything. Causality does not need time. Causality is what is real, and time is the shadow it casts along each observer's path. There is a remarkable piece of evidence for this inversion sitting inside the equations of physics themselves, and it surprises almost everyone when they first meet it. If you write down the fundamental laws that govern how particles move and interact, the profound rules at the base of physics, you find that almost none of them care about the direction of time. Run the equations forward, and they describe the world. Run them backward, with time reversed, and they describe a world that is equally allowed, equally consistent with the laws. At the most basic level, the physics does not contain an arrow pointing from past to future. The laws are, as physicists say, time-symmetric, and yet our world is drenched in a direction. Eggs break, but do not unbreak. We remember the past and not the future. Cause comes before effect, always. If the most profound laws have no built-in direction of time, then the direction we experience so powerfully cannot be coming from the laws. It must be coming from somewhere else, from the arrangement of things, from causal structure, and the way disorder grows, rather than from time being a fundamentally forward-flowing thing. This fits the inversion perfectly. If time were the profound primary reality, you would expect its forward direction to be stamped into the basic laws, but it is not there. What is there, threaded through everything, is causal order, the fixed structure of what can influence what. And from that causal order, together with the particular ordered way our universe began, the whole felt architecture of time seems to be assembled. The sense of a fixed past, an open future, a moving present. We keep looking for time as the foundation and finding instead that it has to be built up out of something more basic. The reading analogy holds all the way down. When your eye moves along a line of text, the sensation of the words arriving in sequence is entirely real, but it is produced by you, by the act of reading, not by the words flowing off the page. The sentence sits there complete and motionless. And the causal structure of the world, this theory keeps suggesting, is like that sentence, fixed and whole, while the flow we feel is the motion of our reading, generated from within, laid over a reality that is not itself flowing at all. This is the most profound inversion of the night, and I want to make sure the everyday weight of it reaches you, because it is not only an abstraction about physics. You feel time passing. You feel the present slipping into the past, the future arriving moment by moment. That feeling is real as a feeling, and nothing tonight is going to take it from you. But relativity is suggesting that the feeling is not a direct perception of a fundamental flowing thing out in the world. It is more like the sensation of moving your finger along a fixed causal structure, reading it off in order, the way your eye moves along a line of already written text and produces the experience of the words arriving one after another, even though the whole sentence was there on the page at once. The words do not flow. Your reading of them flows. And time, this theory whispers, may be like that. The causal structure is written, fixed, and complete. What flows is our reading of it, from the inside, along the particular path each of us takes. And this is exactly the thought that the mathematician who reshaped relativity took hold of and followed to its conclusion. If causality is the real structure, and space and time are the shadows, then perhaps we should stop imagining reality as a three-dimensional world that changes as time flows past it. Perhaps we should picture the whole thing at once, all of space and all of time together, as a single four-dimensional object, complete and unchanging, whose internal geometry is the causal structure we have found to be so absolute. In that picture there is no flow, because the whole of time is simply there, laid out like a terrain you could survey from above. It sounds impossible or mystical, but it came from following the mathematics of the interval with complete seriousness, and it has been the working picture of fundamental physics for over a century. The man who first saw it clearly had once taught the young Einstein, and had not been especially impressed by him. His name was Hermann Minkowski, and in a single lecture in 1908, he told the world that space and time were about to fade into shadows. Part 10. Minkowski's Radical Idea. Hermann Minkowski was a mathematician of the first rank, and in the 1890s, at the Zurich Polytechnic, one of his students was a restless young man named Albert Einstein, who skipped lectures, irritated his teachers, and did not seem, at the time, destined for greatness. Minkowski, years later, reportedly remembered him as a lazy dog who never bothered much about mathematics. So there is a real irony and a real sweetness in what happened next, because it was this same Minkowski who took his former student's physics and gave it the mathematical form that would carry it into the most profound reaches of the century. The lazy dog had, in 1905, quietly overturned the nature of space and time, and it was the old professor who saw, more clearly than Einstein himself at first, what that overturning really meant. In 1908, Minkowski stood before an assembly of German scientists in the city of Cologne and delivered a lecture that began with one of the most remarkable sentences ever spoken in physics. The views of space and time, he said, that he wished to lay before them had sprung from the soil of experimental physics, and therein lay their strength. And then the line that still gives people chills, more than a century later. Henceforth, he declared, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Space alone, gone. Time alone, gone. Only their union, the four-dimensional thing he was about to describe, would remain as something real. He had listened to the physics telling us that observers disagree about space and disagree about time, but agree about the interval, and he had drawn the only conclusion the mathematics allowed. Space and time separately are shadows. The union of them is the reality. What Minkowski proposed was a genuine change in what we take the universe to be, and it is worth stating plainly because it is easy to let it slide past as a figure of speech when it is meant with complete seriousness. He proposed that reality is not a three-dimensional space that changes as time flows through it. He proposed that reality is a four-dimensional space, with time as one of its four directions, and that this four-dimensional thing does not evolve or flow or change, because there is no additional time outside it for it to change with respect to. It simply is. All of space and all of time, past, present, and future, laid out together as a single fixed geometric object. He called it the world, and we now call it spacetime, and the mathematics of it became the language in which all of modern fundamental physics is written. Take a moment to picture what he is asking you to see, because it is one of the great imaginative leaps a human mind has ever been asked to make. In the ordinary picture, this present moment is special, a thin, bright edge of now, with the settled past behind it, and the open future ahead, and the whole world of three-dimensional space is racing along that edge, endlessly turning future into past. Minkowski takes that picture and freezes it, and then steps back to see the whole of it at once. In his view, there is no special present, no moving edge, no racing. There is a four-dimensional terrain in which every moment of time is a location, just as every point of space is a location. Your birth is at one place in this terrain. Your death is at another. This moment, you listening, is a third. And all of them are simply there, together. The way the whole of a mountain range is there, even though a hiker walking through it experiences only one valley at a time. Within this terrain, the points are events, specific happenings at specific places and moments, and the objectively real relationships between them are the geometric ones, the spacetime intervals, which, as we have seen, are really the causal relationships. So the causal structure we found to be so absolute becomes, in Minkowski's picture, simply the geometry of this four-dimensional world, the pattern of intervals between its points, the shape of the thing. And our experiences of space and of time separately, our measurements of distance and duration, are revealed as nothing more than the particular way each of us slices this four-dimensional object into a stack of three-dimensional nows, one moment after another. Different observers slice it at different angles, which is exactly why they disagree about space and time. But the object being sliced is the same for all of them, and its geometry, its causal structure, is what is truly real. It is worth knowing that not everyone welcomed this idea at first, including the one person you would most expect to. When Minkowski first recast relativity in the language of four-dimensional geometry, Einstein was not impressed. He is said to have grumbled that his old professor had dressed his physics up in superfluous learnedness, a lot of unnecessary mathematics piled on top of a physical idea that had been perfectly clear without it. Einstein had reasoned his way to relativity through physical intuition, through thought experiments about trains and light beams and falling observers, and Minkowski's abstract four-dimensional space struck him for a while as an elegant but pointless reformulation, mathematics for its own sake. It is one of the quiet lessons of the history of physics that the man who discovered the thing did not, at first, see what it truly was. Then came the years when Einstein tried to extend relativity to include gravity, and everything changed. To describe how gravity bends the paths of objects and the course of light, he found he needed to talk about space-time curving and warping, and there was simply no way to say any of it without Minkowski's four-dimensional geometry. The superfluous learnedness turned out to be the indispensable language. By the time general relativity was complete, around 1915, the four-dimensional world was not an optional dressing on the physics. It was the physics. Gravity itself became nothing more than the shape of Minkowski's spacetime, bent by the matter within it, and the paths of planets and the falling of an apple became just the straightest possible lines through a curved four-dimensional world. Einstein had come all the way around to his old teacher's view, and built on it the crowning achievement of his life. The picture we are exploring tonight is not a fringe interpretation. It is the ground floor of our best theory of gravity, the framework inside which every modern description of the cosmos is written. I have to tell you the human ending of Minkowski's story, because it carries a weight that the mathematics cannot. Having given relativity the geometric form that would let it grow into general relativity, into the understanding of gravity, of black holes, of the expanding universe, of gravitational waves rippling across the cosmos, Hermann Minkowski did not live to see almost any of it. A few months after that lecture in Cologne, in January of 1909, he was struck by a sudden attack of appendicitis, and within days he was dead, at the age of 44. He had told the world that space and time were shadows, and that a four-dimensional reality lay beneath them, and then, almost at once, he was gone from that reality himself, leaving the idea behind to be taken up by others and carried further than he could have dreamed. There is something almost unbearably fitting in it. The man who first understood that every life is a fixed shape in a four-dimensional world, complete from birth to death, saw his own shape close far too soon, and never watched the astonishing places his idea would travel long after his own segment had ended. His four-dimensional world outlived him by more than a century, and is more alive now than ever. Part 11. You are the line. Let me bring Minkowski's four-dimensional world all the way home, out of the abstract and into your own body, because this is where the idea stops being about physics and starts being about you. In this picture, you are not a three-dimensional object that moves through time. You are a four-dimensional object. You have length, breadth, and height, the 3 dimensions of space. But you also have extent in time, from the moment of your birth to the moment of your death, and that temporal extent is just as much a part of your true shape as your height is. In the 4-dimensional world, you are not a thing that travels from your birth toward your death. You are a shape that stretches between them, a long, thin, intricate curve threading through the terrain of spacetime. And physicists have a name for that curve. They call it your world line. Try for a moment to see yourself that way, because it is one of the strangest and most peaceful shifts of perspective available to a human being. Imagine lifting up out of the flow of your own life, out of the relentless forward press of one moment, giving way to the next, and seeing your existence whole all at once from outside. You would not see a person moving. You would see a single quiet curve, beginning at a point that is your birth and ending at a point that is your death, and along its entire length, at every position, there you are. There is the infant. There is the child on a summer afternoon you had forgotten. There is you, right now, listening to these words in the dark. There is you, older, in a moment that has not yet arrived from your point of view, but sits there on the curve nonetheless, already part of the shape. Every moment you will ever live is somewhere on that line, motionless, complete, present, all together, like the notes of a song written out on a page rather than played one at a time. Now hold the question that this picture forces, the one that turns everything, and hold it gently. Do you move along that world line? In the ordinary picture you would say, yes, obviously, I am here now, and I will be there later. I am travelling along my own life from one end towards the other. But Minkowski's answer is quieter and stranger. No, you do not move along the line, because there is no separate outside time for you to do the moving in. Movement means being at one place at one time and another place at a later time, and the world line already contains all of your times. There is no further clock ticking outside the 4-dimensional world, measuring how fast you slide along your curve. The curve is simply there, all of it, and you are not a point crawling along it. You are the curve. You are the whole line, the entire shape from birth to death, existing all at once in the 4-dimensional world. And the sense of moving through it is something that happens within the shape, not to it. Let me sit inside this picture with you for a moment, slowly, because it rewards a patient look rather than a quick one. In the ordinary way of feeling your life, you are a small point of nowness, travelling forward, leaving a trail of vanished past behind you and moving into a future that does not yet exist. Everything ahead is dark and unmade. Everything behind is gone. Only the thin, bright point where you are is real. But the 4-dimensional picture asks you to set that feeling down, just for tonight, and see the whole world line as equally real along its entire length. The moment of your birth is not gone. It is still there, at its own end of the line, as real as this one. The moments ahead of you are not unmade. They are already there, at their own places, waiting not to be created, but simply to be reached by the part of you that experiences things in sequence. Nothing on the line is more real than any other part. The whole shape exists all at once, complete. If you can hold that even for a breath, you may notice that it does something unexpected to the fear of time. So much of our unease about existence comes from the sense that everything is slipping away, that each moment dies the instant it arrives, that we are forever losing the present to the past and being pushed toward an end. The 4-dimensional picture quietly denies all of that. Nothing slips away because nothing was ever flowing. The moments are not being lost behind you. They are staying exactly where they are on your world line, permanent, untouched, as fixed as points on a curve drawn on paper. What moves is only your attention, reading along the line, and even that movement may be more about the nature of a remembering mind than about any motion in the world itself. The line does not go anywhere. It simply is, and you are all of it. This is the picture that physicists and philosophers call the block universe, and I want to be careful and honest with you about its status, because it matters. The mathematics of relativity does not force this interpretation on you. There are serious, thoughtful physicists who accept every experimental result we have discussed and still resist the full block, who hold that only the present is truly real, or that the past and present are real while the future remains genuinely open. That debate is alive and unsettled, and anyone who tells you it is closed is overselling. But the block universe is the most natural reading of the geometry, the one that takes Minkowski's four-dimensional object at face value, and it follows with unsettling directness from the relativity of simultaneity we watched dissolve the universal now. If there is no shared present that sweeps through the universe, if your now and another observers now cut the events of the world at different angles, and both are equally valid, then the events they disagree about, including events in what you call the future, must be just as real as the events in your present, because they are somebody's present, and no present is privileged. The future must already be there, as real as here, or the whole even-handedness of relativity falls apart. Before we rest in this picture, I have to deal honestly with the fear it tends to provoke, because it is the place where this idea gets twisted into something it does not say. If the future already exists, people ask, fixed and complete in the four-dimensional world, then is not everything predetermined? Are our choices an illusion? Is free will simply gone, since whatever we will do is already sitting there on our world line, settled, unchangeable? It is a natural worry, and it has been used to argue that relativity proves fatalism, that nothing we do matters because it is all already written. But look carefully at what the physics actually says, because the leap to fatalism smuggles in an assumption the geometry does not contain. The future being already there does not mean your choices are bypassed. It means your choices are part of the shape. Your deliberations, your weighing of options, the moment you decide one thing rather than another, all of that is woven into your world line, and it is precisely by making those choices that the future comes to be what it is. Nothing reaches in from outside and imposes an ending on you against your will. The four-dimensional world does not contain a future that happens whether you choose or not. It contains a future that includes your choosing as one of the threads that makes it so. To say it is already there is not to say it is forced. It is only to say that the distinction between what you will freely decide and what will happen is, in the end, no distinction at all, because your free deciding is one of the things that happens. The block does not turn you into a passenger. You are still the author of your world line. It is only that the book, once written by your living of it, does not then unwrite itself. Sit for a moment in the quiet that this brings, because although it sounds at first like it should be frightening, there is a strange calm folded inside it. If the block universe is right, then nothing that has ever happened is truly lost. Every moment you have lived, every person you have loved, every ordinary afternoon that felt like nothing at the time, is still there, fixed forever at its own place in the four-dimensional world, not erased by the passage of a time that was never really passing. The child you were is not gone. That moment still exists, back along your world line, as real as this one. Einstein himself reached for this consolation near the end of his life, when his lifelong friend Michele Besso died. Writing to Besso's family, he said that people like them, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. He was not offering an empty comfort. He was saying what the geometry says. In the four-dimensional world, Besso had not vanished. His world line was simply complete, and it was still there, woven permanently into the fabric of a reality where nothing that exists at any moment ever stops existing at all. Part 12. The Graph Paper with No Pages. We began the night with a meter, a simple mark on a ruler, and I called it a line we agreed to share, a bit of grid we lay across the world. I want to return to that image now. because we are finally in a position to see how far it reaches. Think about what a ruler actually is. It is a set of evenly spaced lines that human beings invented and agreed to use, a grid we impose on things in order to talk about them. There is nothing about the world that comes with tick marks on it. The centimetres and the inches are ours, drawn on, a convenience for comparing one thing to another. And what relativity has shown us, step by step tonight, is that this is true not just of the marks on the ruler, but of the whole notion of distance itself, and of duration, and of the separation of space from time. They are the grid. They are the lines we draw. The four-dimensional world beneath them has no such lines of its own. There is an image that captures this better than any equation, and it comes from thinking about how we experience the passage of time as though we were reading a book. Imagine that all of us are reading the same flip book, made of graph paper, and that the story is the history of the universe. Every event that ever happens drawn somewhere on the pages. We all agree on the events of the story, the happenings themselves, the firecrackers, and the heartbeats, and the collisions of worlds. But we do not agree on where those events fall on the page, because that is the spatial distance between them, and we have seen that different observers place them differently. We do not agree on how many pages lie between two events, because that is the time between them, and we have seen that different observers count differently. We do not even always agree on the order of the pages, on which event comes on an earlier sheet and which on a later one, because for causally disconnected events, the sequence itself is not fixed. And yet we are all, unmistakably, reading the same book. Now push the image to its breaking point, the way the physics demands, because this is where distance finally reveals what it is. There is no graph on the paper. The grid lines we have been reading the positions off of, the ones that let us say this event is here on the page and that one is there, are not printed on the sheets at all. We draw them ourselves, each of us, at our own angle, in order to have something to measure against. And go further. There are no pages either, no separate sheets to be counted, no stack of moments laid one atop another, because the division of the four-dimensional world into a sequence of nows is exactly the slicing that different observers do differently, and go all the way. There is no book. There is no bound object with a first page and a last, no container holding the story in order. There is only the four-dimensional world, whole and undivided, and without any grid of its own, and all of it, the pages, the numbering, the graph paper, the very idea of distance and duration, is something our minds bring to it so that we can perceive it at all. We impose the grid because we cannot take in the whole at once, but the grid was never in the world. This is what it means, in the end, to say that distance is an illusion, and I want to be precise about the word, because it does not mean what the mystics and the sellers of easy wisdom want it to mean. It does not mean the wall beside your bed is not really there, or that you could pass your hand through it by believing hard enough, or that the space between you and someone you miss can be wished away. The wall is real. The separation you feel is real, as a feature of the grid we all share at our common, slow, earthbound pace. What is illusory is only the belief that distance is a fact about the world itself, stitched into the fabric of reality, rather than a line we draw across a reality that has no lines. Distance is a construct, in the exact and literal sense that we construct it, laying our grid over the gridless, four-dimensional world in order to find our way. It is as real and as useful as the lines of latitude and longitude drawn on a map, and as absent from the territory itself. And here is the thought I most want to leave with you from this part, because it reaches past physics and into the shape of a human life. If distance is the grid and not the world, then the separations that ache the most, the miles between you and the people you love, the years between you and the moments you would give anything to return to, the gap between where your life is and where you wish it were, all of these are drawn in the same grid, the one we impose rather than the one the world contains. In the four-dimensional reality beneath the grid, the afternoon you long for is not far away down some corridor of vanished time. It is simply there, at its own place, complete, as real as this night. You are a world line, and every moment you have lived remains a part of your shape, not lost, not erased, not carried off by a river that was never truly flowing. The distance you feel from all of it is real in the only way that touches your evening, and it may not be real in the way you always assumed as a truth about the world. It may be only the grid, and the grid was always ours. There is a comparison that has been used for centuries to make exactly this point, and it is worth borrowing, because it draws the line between the construct and the reality with perfect clarity. Think of the lines of latitude and longitude that cover every map of the Earth. They run in neat curves across the oceans and continents, the equator, the meridians, the tropics, and we use them constantly to say precisely where a thing is. And yet not one of those lines exists on the actual surface of the planet. There is no painted equator running through the sea, no meridian scored into the ground. Sail to where the map says a line should be, and you find only more water, unmarked. The grid is real as a tool and absent as a feature of the territory. It is something we lay over the world to find our way, agreed upon and useful, and entirely our own, and the world beneath it carries no such lines at all. Distance and duration, relativity is telling us, are exactly like those lines of latitude and longitude, except that the territory they are drawn across is not the surface of the Earth, but the four-dimensional world itself. We rule our grid of space and time over reality in order to navigate it, to say where and when, and the grid does its job beautifully, and it is not printed on the thing itself. Different observers, as we have seen all night, rule their grids at different angles, which is why they disagree about the where and the when, just as two map makers, using different starting meridians, would disagree about a place's longitude while pointing at the identical spot of ground. The disagreement was never about the territory. It was only ever about the lines we chose to drape over it. And the territory, the four-dimensional world, with its fixed causal geometry, sits there beneath every grid, the same for everyone, gridless and whole. That is the strange gift hiding inside the coldest-sounding physics. The theory that took away our shared present and our absolute distances hands back, in the same motion, a world in which nothing that ever was has stopped being. It says the separation is a construct, and the connection, the causal thread, is what is real. And it leaves us to sit with the fact that the thing we were most certain of, the plain gap between here and there, was the illusion, while the thing we never noticed, the web of what can touch what, was the reality underneath the whole time. Part 13. Why we feel the distance. There is a question I have been holding back all night, and it is the honest and humbling one, so let me put it to you now plainly. If distance and duration are the grid and not the world, if reality is a four-dimensional object with no flowing time and no absolute space, then why on earth do we experience it the way we do? Why do we live so completely inside a vivid, three-dimensional present, feeling space stretch out around us and time slip relentlessly forward, if none of that is the profound truth of things? The physics has been extraordinarily good at telling us what is real and what is imposed. It has been almost silent on why the imposed layer is the one we find ourselves living in. And I do not want to pretend otherwise, because the honesty is part of the beauty here. Let me be clear about the shape of our ignorance, because even our not knowing has a structure worth seeing. We can write down the four-dimensional world. We can identify the interval, the causal geometry, as the objective reality. We can show in precise mathematics that the split into space and time is observer-dependent, a slicing, rather than a fact. All of that is solid, tested, and as certain as anything in science. What we cannot do is explain why a conscious being, made of matter inside this four-dimensional world, experiences a single moving now instead of the whole of its world line at once? Why is there a felt present at all, a particular moment that seems lit up as real, while the others feel gone or not yet arrived, when the geometry says all the moments are equally there? That question sits at the join between physics and mind, and nobody has answered it. It is one of the genuine open frontiers, said not with frustration, but with a kind of wonder that there is still so much room left to understand. Notice how completely our very language is built around the thing physics cannot find. Every sentence you speak is soaked in tense, in was and is and will be, in the assumption that time flows and that the present is a special place we all inhabit together. We say the past is behind us and the future ahead, as though time were a road we walk down. We cannot even describe the four-dimensional world without reaching for words that quietly contradict it, saying that the future already exists, which smuggles in a now for it to already exist relative to. The flow of time is not just a belief we hold. It is woven into the deepest grammar of how we think, so tightly that stepping outside it, even for a sentence, is almost impossible. And that is part of why this mystery is so hard to look at directly. We are trying to understand using minds and words built entirely around the passage of time, a reality in which the passage of time may not be a fundamental feature at all. It is a little like trying to describe silence using only music. The tool and the target are made of different things. There are clues, and they are worth laying out, even though they do not close the gap. The strongest one has to do with the direction of time, the arrow that points from past to future, and it seems to be tied not to the four-dimensional geometry itself, which has no built-in direction, but to something else, to the fact that the universe began in an extraordinarily ordered low-disorder state and has been growing more disordered ever since. That growth of disorder, the steady increase of what physicists call entropy, gives the world a consistent one-way grain, the way a deck of cards that starts perfectly sorted can only get more shuffled. Memory, aging, cause preceding effect, the sense that the past is fixed and the future open, all of these seem to line up with that grain of increasing disorder. So our sense of time's direction may come not from the geometry of space-time, but from the particular ordered way our universe happened to begin. But notice, and this is the crucial honesty, that even a perfect account of time's direction would not explain time's flow. Knowing which way the arrow points is not the same as knowing why we feel ourselves carried along it. A film has a definite order to its frames, a clear before and after, but the film strip does not feel itself being watched, does not experience one frame lighting up as now while the rest wait in the reel. The whole strip is simply there, and the four-dimensional world is like that strip, all its frames present at once, and yet somehow, for us, one frame is always now, always lit, always the moment we are in, and it will not hold still. Why the reading of the world line should feel like a flow, why there should be a moving now for a being who is, in the geometry, simply the whole line at once, is a mystery that our best physics has not touched. It may be that the answer lies in the nature of minds rather than the nature of space-time, in how a brain that records the past and predicts the future necessarily generates the sensation of a present edge. Or it may be that we are still missing something fundamental about time itself. We do not know. There is one more layer to the mystery that I want to lay before you gently, because it is where the frontier of physics is actually reaching tonight, and it takes our whole story one step further than anything settled. All night we have treated the four-dimensional world, space-time itself, as the bottom layer, the real thing beneath the shadows of distance and duration. But some physicists now suspect that even space-time is not the true bottom. If distance and time can be observer-dependent projections of something deeper, they ask, why should the four-dimensional geometry itself be fundamental? Perhaps space and time, even in their unified Minkowski form, are themselves emergent, arising from some more basic structure that is not spatial or temporal at all, the way the smooth flow of water emerges from countless molecules that are not themselves wet. In several of the leading attempts to unite gravity with quantum physics, spacetime is not assumed at the start, but appears as a large-scale pattern, woven in some of these ideas, out of the quantum connections between the pieces of the world. I want to be completely clear that this is frontier speculation, not established fact, and it is labelled as such by the people pursuing it. Nobody has a finished theory of what lies beneath spacetime, and it is entirely possible that spacetime really is the bottom after all. But the fact that serious physicists can even ask the question tells you how far the ground has shifted since we started tonight with a meter and a wall. We began by doubting that distance was fundamental, and we found the interval beneath it. We doubted that space and time were separate, and we found the four-dimensional world beneath them. And now, at the very edge of what anyone understands, there are people quietly doubting that even the four-dimensional world is the end of the descent, wondering what deeper things space and time might themselves be shadows of. The lesson of the whole night, that the solid thing you started with is a projection of something more basic, may simply keep going, layer beneath layer, further down than we can yet see. I find I do not mind not knowing, and I want to offer you that same peace, because this is a place where the not knowing is not a failure, but an opening. We have followed the physics an astonishing distance tonight. We have watched distance and duration and order dissolve into shadows, found the causal bedrock beneath them, and seen reality reshape itself into a four-dimensional whole in which nothing that exists ever ceases to exist. And at the very end of that long walk, we arrive at a simple, human question. Why do we feel the way we feel, and the most advanced physics ever devised looks back at us and says, honestly, that it does not yet know? There is something steadying in that, rather than something bleak. It means the world still holds a real mystery at the exact point where the physics meets your own experience of being alive in it, a mystery that no instrument has cleared away, sitting right here in the ordinary feeling of this moment being now. You do not have to solve it to rest beneath it. You only have to let it be what it is, which is genuinely and wonderfully unfinished. Part 14. The Thread That Is Real. So let us come back at the last to your hand and the wall, and to the little gap between them that we began with, because it means something different now than it did a couple of hours ago. That gap felt at the start like the most solid fact in the world, distance itself, plainly and simply there. And we have watched it turn into a shadow. We have seen that two observers cannot agree on how wide it is, that the space of it and the time of it pour into one another depending on who is moving, that the only thing everyone agrees on is not the distance at all, but something underneath it, the causal interval, the answer to whether your hand and the wall could ever be part of each other's story. The distance was the grid, the causal thread was the world, and of the two, it was the one we never noticed that turned out to be real. I want to leave you with the gentlest version of what all this means, the version you can carry into sleep without any weight. Picture the four-dimensional world one last time, the whole of it, every event that ever happens laid out together, and picture the countless world lines threading through it, every particle, every star, every living thing, each one a curve stretching through the terrain. Yours is among them, a single quiet thread running from your birth to your death, touching and crossing the threads of everyone you have ever known, woven together with them at every point where your lives made contact. Those crossings, those places where one thread could reach and change another, are the causal relationships, and they are the realest things there are. You are not, in the end, defined by where you are in space, which is only the grid. You are defined by what your thread touches, by the web of cause and effect you are woven into, by everything you have reached and everything that has reached you. Think back over the strange road we walked to arrive here, because the shape of it is the whole lesson. We began by trusting distance completely, and then we watched two careful observers disagree about a length, and I asked you to hold on to a single sentence that none of them was wrong. We carried that sentence forward as the disagreements deepened, from length to duration to the very order of events, and each time it held. None of them was wrong. It sounded at first like the road to chaos, as though a world where everyone measured differently and no one was mistaken could only dissolve into a fog of private realities, with nothing shared. And instead that sentence led us, step by step, to the exact opposite, to the discovery that beneath all the honest disagreement, there sits one thing every observer agrees on absolutely: the causal structure, the web of what can touch what. The disagreements were never a sign that nothing is real. They were the way the world pointed us, patiently, toward the one thing that is. And notice what that real thing turned out to be. Not distance, which we could not agree on, not duration, which slipped between us, not even the order of events which bent with our motion. The thing that stood firm, the same from every point of view in the universe, was the answer to a single question asked of any two events: could one of them have reached the other? Could a thread of cause and effect ever join them? That is what the interval measures. That is what survives every change of perspective. And so when we ask what is truly real in the relationship between you and anything else in the world, the honest answer relativity gives is not how far away it is, which is only a shadow, but whether you are woven into each other's story, whether your thread and its thread can touch. What you could touch and what could touch you is the realest fact there is about your place in existence. And that web does not come apart. The distances within it may be illusions, negotiable shadows that shift with every observer's motion, but the connections themselves, the causal threads, are absolute, agreed upon by every point of view in the universe, written permanently into the geometry of the world. The people your life has touched are joined to you not by the fragile grid of space and time, but by the fixed structure of what reached what, and that structure does not dissolve. In the four-dimensional world, every moment you shared is still there, at its own place, complete, and the thread that connects you to it was never really a distance to be crossed. It was a line of cause and effect, and those are the things reality is actually built from. The gap was the illusion. The connection was always real. Thank you for taking this long, strange walk with me tonight, out past the edges of distance and time, and into the quiet, four-dimensional world that lies beneath them. If you found something here worth thinking about as you drift off, a like or a subscribe genuinely helps this small channel keep going, and it means more to me than you know. And remember, the next time you feel the distance between yourself and something you love, that the gap may be only a grid we draw, and the thread of cause and connection beneath it, the thing that truly joins you, may never have been a distance at all. Good night, and may you never look at the space between things the same way again.